In this lesson, we're going to talk about direct variation equations, and these are equations. We've looked at them before. We're just giving them a name. So a direct variation equation is an equation where the ratio of two variables is constant, and ratio means a fraction. So when that ratio or division, so whenever the ratio is constant, the relationship is called direct variation. The constant ratio is called the constant of variation. So the form that these equations are going to be written in is y equals something times x. So we've called this thing the pattern before, and so now we're just giving it a more formal name. So that constant ratio, that pattern that we've been looking at, is going to be called the constant of variation. So sometimes the variable that's used here is k for constant. Not sure why they do that, but y equals kx, y equals mx, or y equals pattern times x. So those are different ways that we can talk about this. So what we're going to be doing is trying to find this number to fill into the equation. So to find that constant ratio, we're going to look at ordered pairs, and what we're going to do with that ordered pair is we're going to take the y value and we're going to divide it by the x value. So if I look in this first example, on this graph, it says the amount of money Serena earns at her job is shown on the graph, and we're going to determine the amount she earns per hour. So I'm going to take each of these ordered pairs here, and I'm going to find that ratio. So this first ordered pair is at 440. So I'm going to write the ordered pair like normal. But then to find that constant of variation, I do the y value divided by the x value. So for this one, if it's a y value of 40 and an x value of 4, whenever I divide that, 40 divided by 4 is 10. So since this is a direct variation equation, it should be constant. Let's look at another one and see if it comes out the same. So this second ordered pair is at 880. So I'm going to do that same thing. I'm going to do the y value divided by the x value, and 80 divided by 8 is 10. So we get that same answer. Let's keep looking at them. All right, the next one is at 120. So with that ordered pair, I take the y value and divide it by the x value, and I get the same thing. So no matter which one we take, even if we take this last one where it is at 160, and we divide it out, we also get 10. So that's what it means to be a constant ratio. Any ordered pair that you take and you divide your y value by your x value, you should get the same number, and that number is called the constant of variation. So to answer this question, it says determine the amount that she earns per hour. So since this number stayed the same no matter how many hours we were looking at, this is our constant of variation. So Serena earns $10 per hour. So she works 4 hours, she gets $40. She works 8 hours, she gets $80. So Serena earns $10 per hour. So it just told us to write the constant of variation. That's also the number that would go into that box in the equation. All right, so here we have just like a key concept box. So a direct variation equation is a relationship where the ratio of y to x is a constant, k. You say y varies directly with x. A way that you can tell from a graph if something is a direct variation equation is if it goes through the origin. So notice that on this graph that we looked at up at the top and on this one in this example, it goes through the origin, and that is another key feature of a direct variation equation. So what we're going to look for now is how to use these equations to solve. So sometimes an equation or a question is going to give us a particular situation, like one piece of information that goes together so that we can find that constant of variation, and then we're going to apply that to another situation. So in example 2 here, it says the total cost for cans of soup varies directly as the number of cans purchased. So this right here tells me I'm working with direct variation. Next thing it says is if 4 cans of soup cost $5, how much would it cost to buy 8 cans? So this first statement right here, if 4 cans of soup cost $5, that's the relationship that I'm going to use to find that constant of variation. So when we're looking for that constant, we do y divided by x. So I need to figure out which variable is going to be which. So let's let x represent the number of cans because it's the independent variable. The cost will depend on the number of cans. And we're going to let y represent the total cost. So with this situation, x is the number of cans, so x is 4. Y is the cost, so that's 5. So what I'm going to do first is I am going to find that constant of variation by doing y divided by x. So if I plug those in, I have 5 divided by 4. And so I can leave it like that, or I can go on and divide it out. So 5 divided by 4 would be 1.25. Or we could leave it as 5/4, or we could leave it as 1 1/4. So most of the time when we're working with these situations, we do want to leave it as an improper fraction. So on this one, I'm going to leave it as 5/4. But know that it's the same as those other equations. So now this is my pattern. This is what I'm going to put in that blank. So y equals pattern times x. So I'm going to go in and replace that k with 5/4 so that I can write the equation. Y equals 5/4 x. So that's the first part. I have to write the equation. And so I find the number that I'm going to plug in by taking one specific situation and dividing that y value by the x value. So now that I have this equation, I'm going to use it to figure out how much 8 cans would cost. So with this equation that I just wrote, y equals 5/4 x, I'm going to take that I need to buy 8 cans, which is an x value, and I'm going to plug that in. So this will be 5/4 times 8. So I'm going to plug that into the calculator to see what that answer will be. So 5/4 times 8 gives me 10. So y equals 10. Since y was a cost, we said let y represent the cost, it would cost $10 to buy 8 cans. So with direct variation, we can find an equation and then use it to solve something further. So the first relationship just helped me find that constant of variation, 5/4, and then we use the second part of the equation to actually solve. So the last thing we need to be able to do is to tell if something is direct variation or not from a table. And so to do that, we're going to compare the ratios to check for a common ratio. And the ratio that we're going to use is y divided by x. So for each one of these points in this table, I'm going to take the y value and divide it by the x value, and I'm going to see if it remains constant. So for the first one, I'm going to do 16 divided by 2. And so 16 divided by 2 is 8. Now I'll do the next one. So 32 divided by 4. I'm taking my y value in the table and dividing it by the x value. So 32 divided by 4 is 8. I have to check every single one in order to make sure that it's constant. So the next one is 54 divided by 6. So 54 divided by 6 is 9. So this is why it's really important to check every single part of the table, because sometimes it can just be one value that doesn't match. On this one, it's actually going to be the last two. So 72 divided by 8 is also 9. So since it changes right here, it doesn't stay constant, this is not direct variation because there is no constant ratio. So some of the ratios were 8, some of them were 9, but it was not constant. It wasn't the same thing every single time. All right, so let's look at this next table. So we're going to do that same thing. We're going to look at each point and we're going to take the y value and divide it by the x value. So first I have 25.5 divided by 3. 25.5 divided by 3 is 8.5. So this first ratio here is 8.5. Next, I'm going to do 51 divided by 6. So 51 divided by 6 is 8.5. So that one matches with the first one, but we have to keep going. All right, so 76.5 divided by 9. Also 8.5, so we've got one more, and we have to make sure that we check it, because this one could be different, and that would mess it up. All right, so this is 102 divided by 12. And it's also 8.5. So this one is direct variation because it did have a constant ratio, and that is called the, so constant ratio, also known as the constant of variation. So the constant ratio here is 8.5. So I wanted to find that constant ratio, and this one was 8.5. So every single one in the table had that same thing. The previous one did not. So now that I know that the constant ratio, also known as the constant of variation, is 8.5, I can also write the equation. So remember, it's in this form, y equals pattern times x. That 8.5 is the constant ratio. That's that constant pattern that's going on. All right, so y equals 8.5x, is that equation for this situation. So here we have our two things. So another word for direct variation equations is a proportional equation. So direct variation and proportional mean the same thing. So a proportional equation has a constant ratio. If you do y divided by x, it stays the same every time. On the graph, it will go through the origin. And in the equation, it's y equals pattern x. So whatever that constant ratio was goes in that box. For a non-proportional or non-direct variation equation, the ratios are different, and what that means is that it does not go through the origin. So this one went below the origin. And the equation here is going to have an extra part at the end. It's going to add or subtract something at the very end. So we're going to have something, our rate of change in front of the x, but there's going to be something at the end as well. So direct variation and proportional are the same thing. So it can ask you if it's direct variation, it can ask you if it's proportional, and that's asking the same question. Not direct variation and not proportional are the same thing, so it can be the same question. So based on how the table moves, how the graph looks, the equation is kind of determined from those two things.